Okay, so I've made the final modifications to my circuit. I've changed my transistors to say that I'm using 2N2222As. My diodes, I'm using 1N4001s. I need 2 motors for my line follower, and I need 2 LEDs, so I've added those on as well. I've still got my straight on-off switch and the 1 power supply. At this point, you should have breadboarded it before you go any further. There is no point in converting this to a PCB without breadboarding it and checking it really works. Not what the circuit wizard says it works, but does it really work? If for no other reason, you'll find out if you've actually got the components that you want to use. Having done that, you now need to convert it to a PCB. So we're going to the top, click, next, and you want placement only. Next, next, convert. And at this point, the computer will figure out some layout for the components for your circuit. It may not be a very good plan. I mean, this one isn't, because it's wasting a huge amount of space. It's wasting a huge amount of space because it's got one of the components down here, and we've got crossovers that might not be necessary. The little green lines, let's put it into normal and then we can see what's going on. The little green lines represent the points that should be connected together. Now, if you want a good quality printed circuit board, the components should be as close together as possible, and you should have as few crossovers as possible. So where you can, you remove them. So tidy it up a little bit. I'm going to turn that through 90 degrees. I'm going to move it to here. I don't want to make it so compact that I can't get any tracks in between the components. That would be a big mistake. You might find that the green lines move. Sometimes you've got more than one set of points that are connected to the green line because it's the negative or the positive rail, and then they might move as you move the components around. That's absolutely fine. Now this guy here is connected to this point and this point, so it would make much more sense if he was down there, because now when I put a track in, it can go around and underneath. This is connected across the two. Let's bring it down and across a little bit so it's a straight line. It's amazing how much easier it makes it if you do actually just turn the components so that you've got as many straight lines as possible. What you cannot do is put one component on top of another component. You do have to have some space, but it doesn't want to be wasteful any bigger than these gaps that I've got here, and really you're making it far too big. They would never do that in industry because it would cost too much. By the time you make a couple of million of these boards that are maybe half as big as they need to be again, they've wasted a huge amount of money. Also means all the casings have to be big and stuff like that, so it just wouldn't happen. Now we spend quite a bit of time at this stage on getting this piece right, because if this bit is wrong, everything else gets more difficult. So just spending a little bit of time saying, well, actually, do I need those lines to cross over? That might be a bit better. I've got a few less crossovers there. I'm going to move that to there and see what happens. Interesting. Put that one up there. And I'm literally just going, okay, where's my best positioning? I've made it more compact. I honestly could spend time on this and make it a lot better than it currently is. When you're happy that it's as compact as it needs to be, let's face it, I've got it down to less than half the size, then you need to route it. So you go up to the top, routing options, route all nets, and you want thin tracks. If you're lucky, it'll come up 100% okay. If not, you might get bridges, you might get little blue jump wires, you might get a green line that's been left and it says that it can't connect those 2 points together, so it's left a green line in there. Or you might get, as I say, a blue jump wire, and they need to be removed. And I will show you how to do that in the next video. But let's move on to the next stages, because fingers crossed we are lucky. We then need to add a red copper background to minimize the amount of copper that we're etching away. We need to reduce the size of the outside frame so it's 1 square all the way around. We need to add your name or any piece of text. It's going to come out backwards. So this is line full. Okay, and you need to put it in a gap, and the reason it's on there is so that you know which way round to put the mask in the etch tank. You also need strain holes. Every off-board component should have a pair of strain holes for each wire. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 of them in total. So you literally put them on in pairs. Really, they're a bit close together. I might move them. 1, 2, that would be better. 1, 2, and you mustn't move anything that causes the tracks to overlap each other. You mustn't move anything so that your strain holes go on top of the tracks. Nothing along those lines. So there's the 4 strain holes for that LDR. So I can't do the same here. I have to put them over here. 1, 2, 3, 4, and you gradually add each of those sets of strain holes in. When you've done all of those, you've got a final piece of work. Now what you should be doing on your document, you should have your heading, PCB planning. You should copy and paste the original component placement from the computer. You should then move everything around. You should put the new version in, explain what you've done, put your tracks in, explain what you've done, finalize the tracks if you've had to correct anything, explain what you've done, add the copper background, add the strain holes, add your name or the writing, wherever the text is going to be, explain why, and then when you've finished, you've got a PCB mask and a real world image you need. So you literally go to the side here, real world, there it is. Copy, publish it, paste. A little bit more. So that one's there. And you need the mask, which is artwork. Copy, publisher, paste, and there's my artwork. You could also add a little bit of text in the box saying this is the mask. I will use this for generating the PCB. This is the real world view, shows me where to put the components. So that's the basics of generating it. I will show you how to do problem solving in a different video.